Okay, so we just finished doing part A and we found the E field intensity at the point 00h. And now we're going to do part B. So part B is actually a really long problem to solve out all the steps. So I actually pre-solved this out, but I'm going to walk you through the process of how to solve this. So we have to find what value of h, where E will be a maximum, and then what it is. So the value of h first, and then what the maximum is. So we're going to have to like solve for the value of h where it is a maximum, and then plug it back into the E field equation. So let's go ahead and look at how we would do that. So we found our E field from part A, right, which is here. So this is our E field intensity. And now we need to find the max E field. So if you recall from Calc 1, when you need a function, when you need a max or a min of a function, you need to find the inflection points. And the inflection points, if you were graphing like a function to find its maximum, the inflection point would be equal to 0 because the derivative is always a slope, right? It's like if you take the derivative at any point, it will give you like the tangent line at that point. So like the slope at that point. So if the tangent line here is equal to 0, you know it's either a maximum or a min. So when we take the derivative of this EP function, the derivative with respect to z, we're trying to figure out, we're trying to find an inflection point. So mathematically, that's what we're doing here. Okay, so we take this expression for E, right? And we're taking the derivative with respect to z and setting it equal to 0. So we're trying to find that inflection point and we're plugging in our E value here. So we pull out our constant, right? And then we're taking the derivative of this expression still here, okay? And we pull out our constant and then we divide 0 by our constant, okay? Which means that we can cancel it out of our expression here. So 0 divided by this is still 0. And now we still have the derivative over here. So when we do this derivative, the way that we're doing it is the chain rule. So f prime g minus g prime f. So this would be our f and this would be our g. So we have first the derivative of z, right? This f prime is 1, and then multiplied by g, so plugged in here, okay? And then minus this g prime, so the derivative of this part right here, multiplied by f, which it would be z. So in this case, this prime is representing a derivative. So the derivative of f multiplied by g. I know that some of these charged elements have a little prime notation, but you should pretty easily be able to tell the difference in depending on the context. It should hopefully be obvious. If it's not, I will try to really point it out and hammer that point home. Okay, now we get into some ugly algebra. I actually encourage you guys to look at the link in the description and try this algebra for yourself. This is potentially longer than you might see on an exam problem. I would assume that you might have a problem that would ask you for the maximum, but I don't know if the math would be this complicated. But I do think in general it's actually a good algebra review. Okay, so we're simplifying here. Okay, multiplied by 1 plus minus a negative, so we're simplifying here. Multiplied by 2z squared, so simplifying here. So, okay, we're now going to take and set these equal to each other. Equals to, I forget a negative here. So, minus plus, maybe let's see if it works out anyways. Okay, so equals 0 by 2z. So in this case, we're multiplying both sides by z squared plus b squared to the 3 halves because we have a negative 3 halves here and we have a negative 5 halves here. And if we multiply positive 3 halves by negative 3 halves, it will be able to give us 1. So we can simplify the expression on this side, and then we can simplify the expression on this side because 5 halves multiply to that power multiplied by 3 halves is actually addition essentially here. So it's going to be able to turn this expression into z squared plus b squared. So we have z squared plus b squared to the negative 1, right? So then what we're going to do is divide by z squared plus b squared to the negative 1, so dividing it. And dividing something by this to the negative 1 is going to be equal to this. So this negative 1 is basically going to cause it to like end up on the numerator. So again, just algebra review here. If this is difficult for you, please backtrack through this problem and kind of look at some of these steps and highlight what might be complicated here. Okay, so -1, so we have z squared plus b squared. Okay, and now at this point it gets a lot more simple, right? So we have z squared here, 3z squared, so 3z squared minus z squared, so we have b squared is equal to 2z squared. Simplifying a little more, and then the square root of b squared over 2 is going to be equal to b over the square root of 2. So we, just to recap, in between all of our algebra here, what we did was we set the derivative with respect to z of our e field equal to 0. We did a bunch of algebra, right? A whole bunch of algebra. And then we solved for b over the square root of 2 is equal to z. Okay? Just double checking. I'm kind of thinking that I might have done a weird negative thing here, but for some reason this math worked out. So if you find a mistake here, let me know. Okay, so, but the final answer is correct. There might be an intermediate step where I swapped a negative. Okay, so plug in your z answer to e to get the max. So that's the second part of that question, right? Because the first part of that question in part B, if we scroll up, said at what value of h will e in part A be a maximum? So we found the value of h, right? And then we needed to plug it in and find the E field maximum. So we did, we just took this and then we solved for our z, and in this case z is equal to h, yeah? So this tells us where it's a maximum, the height that it's a maximum, and now we're plugging in the z answer to get the E field maximum, the actual value of the E field maximum. So we're plugging this back in to E. Okay, so we plug that back in, and again, we're going to get deep into the algebra here, okay? So we plug this in for our h, or plug this in for our z value, and I'll just write z is equal to h, yeah? Z equals h. So just remember that throughout this problem here. So, all right, so we have b squared over 2, so that turns into b squared over 2 plus b squared to the 3/2 over, and then b over the square root of 2. So we're actually going to combine the denominator here, so b squared, so 2b squared over 2, just kind of combining those fractions, and then on the bottom it's going to give us this 3b squared over 2, okay, to the 3/2. And then we're going to be able to do some kind of algebra magic here. So when we have b squared over 2 to the 3/2, it's the same as b squared over 2 times 1/2 times 3, right? And if we note on the top here, this b over the square root of 2 is actually equal to b squared over 2 times 1/2. These two are equal. So just note there that those are equal. So we're actually going to be able to do some canceling here. So we have b squared over 2 to the 3rd, right? And we're going to be able to simplify our expression and get this out of the numerator, so this guy. And then we're going to notice that this turns into b squared over 2. And then we are going to pull our b squared to the outside, and then go ahead and, because with this b on top here from our first part, we're going to simplify so that we just have that b in the denominator, and then this whole part is just going to be a number. So we can just sort of like either plug that into a calculator or, do some more math magic here, because we have 2 and 1/2, etc. And so in the end, we're going to end up with this as our maximum E field value. So algebraically, this is more complicated than maybe you might see on an exam, but I have seen a lot of you guys struggle with algebra, so please, I think that this problem is a really good exercise to try to mess around with your algebra. So it really covers a lot of different rules and what you can and cannot do in terms of algebra and how to simplify things in a way that may not be obvious right away. So this problem is just tedious because of the algebra, but here's your answer here. So this is what the value would be of your maximum E fields at the height of b over 2, over the square root of 2. So that is part B. Next, we're going to move on to part C, and we're going to answer the last question, which is explain why E has a maximum at that location.